All right, let's start this assignment. Think about it. Write an explanation of what the difference is between an intersection and a union of two inequalities. An intersection is what the solution of the inequalities have in common. A union is the combination of all the solutions of both inequalities. So intersection is what they have in common, and union is a combination of all of the solutions together. All right, we're going to write what we see on each of these number lines. In number 2, we'll notice that all the shading is to the right of -1, which indicates values are shaded that are bigger than -1. So x is larger than -1. In 3, we see numbers that are shaded in between -3 and 2. So I'm going to write a 3-part inequality. -3 is less than or equal to x is less than 2. Be sure that your inequalities all point toward the -3. In 4, I see a disjoint set. For a disjoint set, the only way to state this is using a disjunction or an OR statement. So just reading what's on the number line, x is less than 0, or x is greater than or equal to 3. In 5, we see everything shaded on the number line with the exception of -3. So x just simply is not equal to -3. And in 6, we see values shaded in between two numbers. They are in between 0 and 4, so 0, x, and 4. Write them from left to right just as you see them on the number line. 0 is less than or equal to x is less than or equal to 4. And lastly, for 7, we see another disjoint set. So x is less than -3, or x is greater than -1. All right, in 8 through 13, we are solving or stating the inequality has no solution, showing supporting work, and circling and boxing our final answer. All right, we're going to solve this pretty much like we solve an equation. I'm going to subtract 2x from both sides, and then add 7, and then we can divide by 2, and we get, turning this around to say what x is less than or equal to 11. In number 9, we have 5x plus 7 is less than or equal to, and we'll use the distributive property on the right side to write 5x plus 15. Subtract 5x from both sides, and we get the statement that 7 is less than or equal to 15. That is a statement that is always true. 7 is less than or equal to 15. So if that is always true, then the solution is all real numbers. That means no matter what number I replace x with, we will always have a true statement. So for instance, 5 times 1 plus 7 will always be less than 5 times the quantity 1 plus 3. We can certainly check that. 5 times 1 plus 7 is 12. 5 times 1 plus 3 is 5 times 4, which is 20. That's a true statement. No matter what x value I pick, that original statement will always be true. All right, in number 10, I'm going to clear the fractions here first by multiplying through by 4. 3/4 times 4 is 3, so 3x plus 1 times 4 is greater than or equal to 6 times 4, which is 24. And subtracting 4 from both sides, 3x is greater than or equal to 20, and dividing by 3, x is greater than or equal to 20/3. In number 11, I would suggest starting with the inner parentheses first. So -4 times 3 plus 2x plus 2, using the distributive property of multiplication over addition. Let's simplify that. That's 4 times 2x plus 5. And let's keep going. That's -8x minus 20, distributing the multiplication by -4. Now we can work on the other side of the inequality. Distributing multiplication by -3, we get -6x plus 12. So I'm just going to bring that down to this step. I'm going to add 6x to both sides, and then add 20 to both sides. That'll give us 32. And then divide by -2. That changes the direction of the inequality, so x is greater than or equal to -16. Let's move on to number 12. I'm going to multiply each term in this subtraction by 6. When we do so, we can do some canceling of common factors in numerators and denominators. And of course, now that I've done this, I realize I have a mistake. I should have been clearing the fractions. And to do that, we're not going to multiply by 6, but rather by the least common denominator of 12. Let me fix this. So there's our original equation, and we're multiplying by the least common denominator, which is 12. Whatever we multiply by on one side of the equation, we have to multiply by on the other, or it has to be consistent. So now I'm going to cancel common factors. That'll leave us with 2 there, and just with 1 in the second fraction. No other cancellation to do. Something to keep in mind now is that, remember, there are those understood parentheses. So 2 times 3 minus 2x is 6 minus 4x, and I don't have a factor to distribute to the second fraction, rather to the numerator of the second fraction, but I do have a minus sign. So -1, and then minus -3x is positive 3x, or addition of 3x. 12 times -2 is -24. Let's combine our like terms. That is 6 minus 1 is 5, minus x is less than or equal to -24. Negative x is less than or equal to -29 when we subtract 5 from both sides. Dividing through by -1, x is greater than positive 29. For number 13, we'll need to use the distributive property. 5x plus 2x plus 2 is greater than -3x plus 6. Combining like terms, -3x plus 2 is greater than -3x plus 6. Adding 3x to both sides, 2 is greater than 6. That is not a true statement. 2 is not, in fact, greater than 6. So that means that this inequality has no solution. In 14, Ananya has 4 scores on her algebra tests, and we are going to write and solve an inequality to find the score she must earn on the final exam, which is going to count as 2 tests in order to finish with a grade of 77 or higher. So we've got averaging, which happens by adding the 4 tests and the 2 tests that we don't know. We don't know what the score is on the final exam, but we're going to count that as 2 tests. That'll give us a total of 6 tests. So we'll divide that total by 6. And then we want to get a grade that is greater than or equal to 77. So the first thing that we can do is we can do a little simplification. Let's add the figures on the left. That will give us 300. And x plus x is 2x. That total divided by 6 is greater than or equal to 77. Next, we'll need to multiply both sides by 6. In doing so, we're going to cancel that divided by 6. And that will give us 300 plus 2x is greater than or equal to 77 times 6. Let's continue that over here in the available space to the right and move to the top so that we can move down in an organized fashion. Now we need to do the multiplication, and that will give us 300 plus 2x is greater than or equal to 462. Let's subtract 300 from both sides. 2x is greater than or equal to 162, and finally divide by 2. X is greater than or equal to 81. I'm going to answer this in a sentence form. She must earn at least an 81 on the exam in order to finish with at least a 77. All right, in number 15 through 18, we are going to use the third number line to graph the intersection. In 15, the intersection is what the two graphs have in common. So they have in common everything between -4 and 1. And they also, we need to consider the endpoints. The endpoints are, the 1 is filled in on the second graph. That means it's going to be included because it is part of both graphs. The endpoint is not filled in on the top graph at -4, so that's not in both graphs, so we won't include it in the intersection. For 16, what the two graphs have in common is everything 1 and to its right. In 17, what the two graphs have in common is everything between -2 and 3, not including the endpoints. In 18, what the two graphs have in common is everything to the left of 2. All right, in 19 through 22, we're going to use the third number line to graph the union. Remember, the union is the combination of both sets. So we're going to graph everything that was graphed in either the first one or the second one. And in 19, that's the entire number line. In 20, everything that's graphed in one or the other is everything 3 and to the left. In number 21, the combination of the two is everything to the left of 3. We're graphing here anything that's graphed in either one, or we're shading anything that's graphed in either one. In number 22, the combination of those two sets is a disjoint set. That is, we've got two parts that don't necessarily join together. So we're just missing the numbers in between 0 and 2. All right, in 23 through 32, we have two inequalities that are graphed for you, and we're going to graph the, on the third number line, the and or the or. The first is an or, and so that would be a union of the two sets. So the very first thing we're going to do is graph the third number line, and then we'll just simply write down what we see on that number line in simplest form, which is x is greater than -1. In 24, we have the same inequalities, but this time we're putting the word "and" between them. "And" indicates that we're looking for what these two graphs have in common, or their intersection, and then write down what's on the number line. That's x is greater than 3. In 25, we see the two inequalities graph, and if we connect them with the word "and," we are looking for the intersection. We're graphing what is in the first set and also in the second set. That is simply those numbers that are in between -2 and 3. So writing that down, start on the left. Less than x, less than or equal to 3. Write it down exactly as you see it on the number line. And number 26, those same sets. This time we're using the word "or." That's the union, and the two sets combined are the entire number line. So our solution is, in simplest form, all real numbers. And then in number 27, we are looking for the intersection because we use the word "and." Those two number lines have nothing in common, so we're not going to shade anything on the graph, and there is no solution to this inequality. Moving on to 28, we have two inequalities that are connected with the word "or," and so we're going to take the union of the two sets. The union is the two sets joined together or combined. That's a disjoint set. A disjoint set may only be said using the word "or." Now, I've written mine down so that I'm saying it from left to right. The part on the left is x is less than 1, or the part on the right is x is greater than or equal to 2. Doesn't matter what order those are in, it's just that I like to write them as I see it on the number line from left to right. In number 29, we have two sets that are joined with the word "or." So combining the two sets together, we can see the only number not included in their union would be 3. The simplest way to say that is x is not equal to 3. We have the same two sets in number 30, joined by the word "and." "And" indicates that we are looking for the intersection, or what the two sets have in common. Well, they don't cross, so they have nothing in common. So that means that there is no solution and nothing to graph. In number 31, we have two sets, x is less than 4, x is less than or equal to 1, joined with the word "and." "And" indicates what they have in common. So they have in common the set of all x less than or equal to 1. In 32, we have the same two sets joined by the word "or." "Or" is the combination or union of those two sets. And what we see here is x is less than 4. In 33 and 34, we're going to solve a compound inequality. You may perform operations to all three sides of the inequality. So left, center, and right. We'll start by subtracting 3 from -1. Subtracting 3 from 3 minus 2x is -2x. Subtracting 3 from 15 is 12. Now we'll divide by -2. That will give us 2x and -6, but the inequality changes direction because we divided by a negative. I'm going to rewrite that as -6 is less than or equal to x is less than 2, simply because that's how I see it on the number line from left to right. In number 34, we can clear the fraction first by multiplying both sides, or rather all three sides, by 7. Don't forget to distribute times 7 to both terms in the center. Now let's subtract 7. -28 is less than 4x is less than or equal to 0. Dividing by 4, -7 is less than x is less than or equal to 0. So those are all the values between -7 and 0. We are omitting numbers 35 and 36 from your homework. And for number 37, we are asking if x is equal to negative 6, which of these inequalities is true? Well, if we're looking for a solution to an inequality, just one solution, we can just plug it in and see if it works. If we want to see whether negative 6 is a solution to A, let's take that equation, or rather inequality, and let's replace the x with negative 6. That gives us 8 is less than negative 3. That is not true, so x equals negative 6 is not a solution. Let's take a look at the second inequality. 1 minus 2 times negative 6 is less than 13. That's 1 plus 12 is less than 13. That would be 13 is less than 13. That is also not true because 13 is equal to 13, not less than. Let's take a look at C. 3 minus 5 times negative 6 is less than negative 14. So that would be negative 3 plus 30 is less than negative 14. That would give us 27 is less than negative 14. Well, that's not true either. Let's try our last one here. Negative 5 minus 3 times negative 6 is greater than 10. Negative 5 plus 18 is greater than 10. That would be 13 is greater than 10. That is a true statement. So negative 6 is a solution to D, or it makes the inequality a true statement.